peptides weren't known a couple of years ago. Very few people were talking peptides, only the nerds really. And frankly, AI either. Very few people were talking about AI. Yet both AI and peptides have been really everywhere for decades. But it's only now that they're becoming relevant and concrete, because now we understand the power of a peptide. Now we can actually discover a peptide. And AI is a tool that now consumers can actually use more and more. And this is why it's becoming more and more relevant, but they have always been there. So what's a peptide? A peptide on the left-hand side that's kind of how a peptide looks like. They're usually signaling a messenger, so they tell the body what to do. They signal, and once they signal, there's a cascade of events that occur in your body, and then the body just gets rid of it. I call it the language of life, because basically every signal in your body, anything you do goes through a peptide. So whether it's us, whether it's a plant, a bacteria, an animal, all living species signal through peptides. So they're a very important molecule in nature. A peptide usually is part of a protein. That's the middle one. Protein are these massive, I call them peptide carriers. They're massive globular molecules, and within them you find these little peptides hidden within the protein structure. So if you think about it, a protein is a carrier of peptides. The problem is that we have not been able as humans to discover those parts of the protein that when released become a peptide, an active peptide. That's the real issue, and I'll explain a little bit further. So if you take that middle one, which is a protein, and you kind of unfold it, it's like a string that you kind of unfold. That's the bottom line. You can write it in what we call alphabets or amino acids. So that's the bottom line. That's an open protein sequence. And a peptide is simply a part of that sequence. And not every peptide is active, but sometimes you'll find a part in that protein. Once you cleave it, once you break it out of the protein and it's released, it becomes an active peptide, and it has a very important function. And this phenomenon actually is really interesting, because in nature, if you think about it, this phenomenon has occurred a lot. Like proteins would carry peptides, and under certain conditions, let's say your blood pressure is too high and you want to lower it. So the protein would break up a peptide from it to lower blood pressure. Or you get cut. So your proteins in your skin will release certain peptides that would reduce inflammation, help the cells grow, etc. So it's a really interesting, these are blocks within the protein that are only released under certain conditions. Usually repair, positive conditions, or positive effects of those peptides under certain conditions. So why now? That's one of the reasons I was looking into it at the beginning when I first started understanding where could we actually apply our technology. And I looked at many different molecules. There's many different molecules out there. And peptides came as the top of all these types of molecules, because they share a lot of similarities, one of which is they're very efficacious and they're safe. So efficacy is very important. We want to create things that bring together both the natural world, but also efficacy, because sometimes when people go too natural, it's not that efficacious, or very efficacious is very synthetic. It's really bringing those two together. So peptides is really interesting because it has that efficacy part and safety. They're also high selective molecules. So that means they, like I showed you at the beginning with the human body and the different targets in the human body, they usually are very selective. And you can say, I want to alter this specific pathway in the human body. You can actually, or target, you can actually find a peptide that would selectively bind and cascade a signal. They're also very predictable from a metabolism perspective. And what I mean here is that when the body uses a peptide, it can get rid of it. Very few molecules actually do that. Very often they just accumulate, which isn't good. So here the body can actually break up peptides into amino acids like the protein, and that goes back into making more protein. And so forth, lower regulatory barriers, et cetera. But at the same time, when I first started a few years ago, when I first started Nuritas, one of the biggest challenges with peptides had been always they were known to be poorly bioavailable or not stable. That was kind of the idea of what peptides. It were super efficacious, high selective, all the positives, but they weren't known to be bioavailable nor stable. And the reality is that what's interesting, when I first came into the field, I realized that the issue was not that they weren't bioavailable or stable, is that human technology and where humans have looked at peptides, they've looked at a very small pool of peptides. Peptides, if you think about it, they're the largest space known to humankind. There are infinite numbers of peptides, and it's very hard for humans to explore them all. So far we've relied on wet laboratories. So these are labs around the world to test peptide at a time, but that takes too long and it's too expensive. And as such, we've only explored a very little space. But through AI, and this is where my background came in, when I came into this area, I'm like, it's a data problem. There are so many peptides. We need to explore more of these peptides. And the only way you can explore them is through the use of artificial intelligence, to mimic many, many different brains, and to explore many, many different peptides all at the same time, but rapidly. And this allows us then to explore more of that space. So you're not just focused on hormonal type peptides, which have, are not bioavailable, are not stable, because that's how they have been evolved by nature, but you can explore a lot more other peptides, what we call linear peptides out there, that have a stability framework and also a bioavailability matrix attached to them. And I can explain more. But through AI now, when Nuritas started using AI, it was to help humans explore more of the peptide space. Like I said, it's the largest space known to humankind. And what changed through AI and through Nuritas's technology is that now we can use AI to help us explore all these peptides. But not only can we find these peptides are efficacious, high selectivity, et cetera, on the left-hand side, but we can now find peptides that are orally efficacious, that you can actually take orally and they will have an efficacy, that peptides that are stable in formulation, because obviously when we're creating, like you are creating all these different formulas with peptides, you want to make sure that the peptide is stable, which is the case here. Peptides are stable within the formulation, they're orally available and efficacious. And also what's interesting is that we can produce them from a source material that we've kind of co-evolved with because we've eaten it for thousands of years. Like I'll give you an example later with PeptiStrong from fava bean, for example. And we have many more coming through from different sources. Again, when you eat the fava bean itself, you don't get the benefit because your body breaks it down randomly. But by actively releasing the peptide from the protein, you now can get that benefit that otherwise you won't get. And that's really the interesting thing. So today, this is why in our space, peptides are now on the rise everywhere. More and more people know about peptides, whether it's in the pharmaceutical space, whether it's in the consumer space, in our space, etc. Peptides are on the rise and they're going to become very, very big because now we can explore more of them. Now we can make them, we can find ones that are stable and orally available. Those are the weak points that were in the past are no longer today. And so as we were building the AI system, we were testing hundreds of millions of peptides in the lab. And the AI was learning on which ones were working, which ones gave certain patterns to a cell, how did the cell behave, or tissue, or human, how did they behave under the influence of peptide X, peptide Y, etc. And using that data, the AI now can go and explore more and identify for each of the targets in the human body a solution. What Nuritas really had done over the past few years is that it found a way to speak the language of nature, which is the language of peptides. It found a way to bring together the best of life sciences and how peptides can signal and modulate different pathways in the human body together with an AI system. And that's actually, it's not easy. It takes a decade at least to get it right in terms of when you bring a mathematician, a computer scientist, and a biologist, chemist, etc., in the room, they speak very different languages and they see problems very differently. And you have to create a unique language between them. And that takes years already to get it right. But also you have to An AI system is not going to understand biology very quickly, and biology is not going to understand AI either, but you have to translate what one is saying to the other. So we built a lot of software behind the scene, separate to the AI model, just to translate a lot of that modeling of a cell, a lot of how biology works, ultimately at the molecular level, into a language that the AI can then pull off. But ultimately, just to continue on the peptide frame, not all peptides are equal. And this is very, very important to understand. Not every peptide is biologically active. You can find a small protein or small sequence in a protein. It's not biologically active. Very few are actually active. The active ones are called what we call bioactive peptides. So bioactive peptide usually has a clinical proof to that action. Also, not all bioactivity is precise. So you can have a clinical, but those peptides may not be precise. And we've coined that precision bioactive peptides from Nuritas. Those are what we call clinically proven. So they have clinicals proving the activity of the peptide. They're built for the precise sole purpose and mode of action that is necessary to have that effect. They're stable in formulation. Like I mentioned to you earlier, they're tailored by nature over hundreds of millions of years. So not all peptides are equal, and this is really important. Not every peptide is bioactive, and not every bioactive peptide is precise. And bringing those together is what Nuritas's goal is, because ultimately we want to improve the lives of billions of people, and we want to create products that truly work, that people feel the difference, and improve health globally. The interesting thing about a peptide as well is that it's cell signaling. And what that means is that because it's the only cell signaling molecule, so the majority of signals in the human body are via peptides, that makes it a very good synergistic companion to many other ingredients. So combinations of, if someone is taking something else, an additional peptide will always work in complementary to that something else. It's not going to be one or the other, which is really interesting as well. And it's both a nutrient and a functional molecule, and that's rare. Peptides are the only nutrient coded in the human genome. So that's really interesting. So they're both nutrients and functional molecules. Again, very, very rare. So the product I know you have that are working with one of our ingredients is the Make Fit one with PeptiStrong. PeptiStrong is a peptide that we discovered through our AI technology. And what's interesting about this peptide is that muscle health, I think people don't talk about, well, they are starting. And I think the whole Ozempic area has even augmented that. As people lose weight, you lose muscle, and has huge dramatic effects on people's health. Not only from a longevity perspective, so, living less than what you should, but also having longer years when you're not well and you can't move is not the purpose of this. Muscle is directly connected to your well-being, your movement, your mobility, how you look. It's the largest organ in the human body. It's basically how you look, whether it's in your face, your body, etc. Your metabolism, 80% of our sugars metabolize in the muscle. Your mitochondria home, so it's literally your energy hub, and that's only what people talk about. There's lots of papers coming out showing its impact on bone density, its impact on brain health, etc., etc. So muscle is really core to all humans, and we should really look after it. And it's not just core to athletes and people in the gym. It literally is all ages. So healthy aging, women's health, of all ages. Menopause, the first thing that occurs is higher inflammation, higher cortisol, lower muscle, and as such, lower strength. But that starts really at the age of 28. Weight loss, massive area as well, where skeletal muscle is important because you don't want fat infiltration within the skeletal muscle. And sport and active nutrition as well. So muscle is really key to all these areas. And this is why we actually went after this area. You remember the two green bodies I showed at the beginning, the areas we go after are areas that are key to longevity and health in general, at all ages, and we should be all on them. And so we discovered PeptiStrong with 5 clear mechanisms, and the right-hand side just shows you some of the mechanisms of the peptides themselves. So PeptiStrong is a combination of a few peptides that target different targets within the human body. It reduces muscle degradation. It improves muscle production. It reduces inflammation. And as a consequence, there's higher mitochondrial count within the cell, so higher energy, muscle is preserved, your strength is preserved. And then what we discovered in the clinicals, as well as we've done many clinicals with this ingredient, we discovered also that bone density is also augmented. We weren't expecting that, but there's a clear rapport from a lot of publications out there between muscle health and bone density as well. I'm not going to go through all this, but ultimately what we did initially was just say, okay, how does it compare now that we've done all the clinicals with PeptiStrong in both women and men? How does it compare to other ingredients within the space of muscle? So when people talk muscle, they usually think creatine, leucine, HMB, and whey. Whey is the protein. How does it compare? Well, it's a lot of X's better than everything that exists in various different ways. PeptiStrong does a lot more than these 4 ingredients, but within the area that ingredient, let's say creatine, works, it's 5 times better. Whey has a certain activity in phosphorylation of S6, for example. PeptiStrong is 4 times better, but it does other things on top of whey as well, etc. Leucine 2 times superior at 100th of the dose, etc. But it also are synergistic with these ingredients. So like I mentioned earlier, peptide is interesting because the mechanism of action is through signaling, which is very different from other ingredients. So it is better, but also synergistic together. That's really, I think, a key learning. PeptiStrong, just to finish off, PeptiStrong is interesting as well because when we looked at it, I just calculated this quickly in terms of how many combinations would have taken us through traditional methods in the lab if we didn't have AI, if we didn't have the magnifier AI technology that Nuritas has. It would have taken 1 quintillion combinations. That's 18 million combinations to find peptides, to find PeptiStrong specifically. But on top of it, to do all those combinations the proper way, it would have taken us 30 million years through traditional ways. And when I say traditional ways, I'm talking about the ways of today, really, which is I'm going to take something in the lab and I'm going to test it. I'm going to test something else and I'm going to keep testing until I find something. It would have taken about 30 million years to discover PeptiStrong through traditional ways and not through AI as we did today. And I think that's super important to grasp. And it's because it has multiple mechanisms. So if you multiply all those different mechanisms and the different peptides that do that in one, and you search all different species or sources for that peptide, this is what you get. I just want to finish off by saying that everyone really, and it's not, I'm not saying this because we're the inventors of PeptiStrong, or I truly believe that muscle is core to our health, our longevity, our energy. One of the statistics I showed you earlier is that it's really interesting for Nuritas, and I'm sure it's super interesting for yourselves as well, in terms of when you know you're impacting millions of people by this shift. So with PeptiStrong, for example, we focused on strength. So there's a lot of papers that show that by augmenting strength slightly, you reduce all-cause mortality. That includes all cancers, all cardiovascular issues, all metabolic issues by 17%. 17% is massive. There's no one drug or combinations of drugs that would have that effect. PeptiStrong does. So by improving strength in people around the world, women, men of all ages, we're literally giving them 17% reduction on top of everything else, on top of the X% strength recovery, on top of the recovery, anti-inflammation, bone density, and all those interesting things that we'll get through PeptiStrong, you are literally giving them years more to live in a healthy situation. So everyone really should be using the Fit for Make Wellness with PeptiStrong inside.
These bioactive peptides, precision peptides that run through the gut, deliver their message to our body chemistry and then essentially dissolve into the body chemistry, right? And are flushed out. Whereas I think isn't the one of the problems with big pharma the fact that they're putting synthetic chemicals into our body chemistry that are not flushed out, that create toxins that build up in the system, whereas Mother Nature is providing these bioactive peptides that cause no problems, no side effects. Did I get that right?
Yeah, absolutely, Truman. So it's really interesting because when I was looking at peptides and other types of molecules at the very beginning of Nuritas, the choices were many. We could go after any type of molecule using AI, but you had to train it. So you had to choose one and do it well. And we chose peptides, and it literally is because of that. Now, there are like lots of different peptides, but what's interesting is that it's the language of nature. It's the way our microbiome communicate with us and communicate together. It's how our cells communicate together. It's literally, like I say, the language of life. And what's interesting, because we have evolved with peptides, our bodies know what to do with them. So when their function is ended, it kills them. And it uses the different pieces called amino acids to create the next variety of proteins. And again, the cycle starts again. And like I say, sometimes if you had to imagine it, it's like a doorman who's told to open the door. And then the person will come and say, open the door, and then just leave. And the person opens the door because they recognize the person that's going to come in. If they don't recognize them, they'll keep the door closed. And that's the signal. The signal creates a cascade of events. The signal is open the door. I recognize this person. He's whatever, he works in this building. And there's a cascade of events, which is the person says it. The person opens the door, lets this person go, closes the door, the person goes, takes the lift. There's a cascade of events started with one single signal, and that's what a peptide does. And then that's it. The signal starts, the cascade of events occur, and the body just removes the peptide when needed, which is not the same for other molecules, Truman. Correct.
Yeah. Thank you.
With whey, for example, what we're saying is that when you're looking at phosphorylation of S6 and the whole cascade of producing more muscle in the skeletal cells. So we did a clinical where we took biopsies and we looked at the cells taking whey versus taking PeptiStrong. And what we showed is that there's 4 times more production of protein within people taking PeptiStrong than taking whey. As an example, that's in one pathway, which is more protein production. What that means is that we're 4 times better. We can amplify the protein 4 times more. You can take PeptiStrong with like a 5 gram and have a 20 gram with PeptiStrong, or you can take PeptiStrong alone and have the same effect as a 20 gram whey if it's 5 gram your baseline, for example. If it's 20, it's 4 times that, etc. So that's kind of fundamentally what we looked at. But also we looked at with creatine, we looked at that was cellular work. So with whey, we did a clinical. With creatine, we did a lot of cell work, because once you can't do a clinical for every ingredient. But when you show that on a cell, from skeletal muscle cells and how they behave under creatine versus PeptiStrong, and you show a massive difference there, it should convey. So 5x superiority in also protein synthesis. So when you're looking at how much protein your cells are producing in a certain time with PeptiStrong versus with creatine, you're sinking 5 times more of PeptiStrong with PeptiStrong, for example.
Wow.
Okay.
Just asked, like,
is there an age limit? Like if I'm 90 years old, is it still going to benefit me? What are your thoughts?
It's really interesting, Mark. So we're doing aging trials, but also aging. We have a really interesting model in the lab before we're going into clinical, where we have older cells versus younger cells and how they behave. And what we're seeing is that the mechanisms we went after with PeptiStrong are fundamental to both young and old. Okay, so they will work in old, and what we're seeing is that they actually have tremendous effects even more as we age, which is really interesting. So, and we've done a lot of that work in the lab, and it's going to be published, hopefully in Nature Metabolism soon. So we're showing some of that work already, and that is all the combinations I showed you, all the references between creatine, HMB, whey, all that's going to be published work soon as well. So that is interesting. And what's also interesting is that the others that I mentioned within the muscle area, let's say leucine, for example, leucine only works when you're younger. As you age, leucine actually loses its activity. Mm-hmm. So having, enriched products with leucine for the older 60 plus, etc., actually would not have an efficacy. And people don't know that, but that a lot of the results we're seeing show that efficacy. So that's one. And your second one, so the aging in your second one, Mark, was on.
It's like, a lot of people want to take PeptiStrong with their protein shakes.
Yeah, absolutely. Because it basically, PeptiStrong is an igniter. Protein is a nutrient, so it's like fuel. But if your engine is kind of slow or you want to kind of get it running more, that's PeptiStrong. So PeptiStrong is an igniter of your engine. And with the nutrient, with protein, you're moving faster. You're reversing your age. You're improving the health of your cell, of your skeletal cell, muscle skeletal cells. And that's really important. And because you can pour so much nutrients on your cells, if they're not consuming it right, it's a waste of protein. It literally is. So with PeptiStrong, it's that igniter. It's how to use. It's a signal to the cells on how to use your protein better. And that's literally what PeptiStrong does.